Hello and welcome back to part 3 of Houdini Basics, and today I'm going to be talking about the different kinds of operators within Houdini. So you may have heard some of these words like SOPs, DOPs, CHOPs. So these are different environments within the Houdini operating system which operate under different sorts of logic. So as we've seen before, this is the object context where we can lay down containers for SOP networks. So for example, I can lay down this box as we've seen, and if we dive inside, we just have this box SOP. Likewise, I can put down a camera and a light. Now I'm locked into this light. I can move it around like so, and the lighting in our viewport changes. So like our box object, the camera also has a SOP network inside. Same with this light. We can also make use of null objects for parent-child relationships. So if I go into this camera and check keep position when parenting, if I press tab and go into my object context menu, I can type in null and connect this to my camera. Now if I look through my camera in the viewport and select a null object and rotate it, the camera moves along with it. I can do the same thing with my box. And as you can see, the perspective doesn't change except for our construction plane because the box and the camera are rotating at once with the null. So the different contexts are abbreviated except for our object context, which we're in right now. The other contexts I'm going to talk about are SOPs for surface, DOPs for dynamics, VOPs for vex, ROPs for render, CHOPs for channel, and COPs for compositing. So we've already been introduced to the SOP context, and basically the SOP context, or the geometry context, is used for geometry manipulation. So up here in our object context, we do have all of these transformation parameters that we can play with, but a really good idea to keep in mind within Houdini is to do most of these operations inside our SOP network. So this box has these same parameters, or we can make use of a transform SOP to do exactly the same thing. So in the first lesson, I made use of a dynamic rigid body simulation, which put down a DOP network inside of our objects network. The DOP network can also be put inside the SOP network, just like other nodes that both of them share. So if I put down a DOP network in here, we have that. And it can also be put on the top level. This is solely based on personal preference, and today I'm going to be working with the DOP network in the object context. So the main difference between a DOP network and a SOP network is that SOPs don't have any concept of time. It's unable to read information from future or past frames. So even though I can lay down an expression here in the box, so if I type in $ for current, t for time, it's going to be moving 1 unit in the x-axis. So every 24 frames, it's going to move 1 unit. But notice it's only reading the current frame or current second. It has no idea what's happening in the past or the future. I'm going to go back to frame 1 and jump up to our object level. So unlike the SOP network, the DOP network is all about reading the future and past frames in order to calculate its simulation data. So the DOP context works on a completely different logic than the SOP context. So if I press tab, I have a completely different menu of nodes to choose from, and the heart of the DOP networks are its solvers. So these are actually the nodes that calculate the simulation data for whichever type of simulation you want to calculate. So for example, we have the cloth solver for cloth, the flip solver for fluids, the pop solver for particles, and we have the pyro solver for smoke, RBD and rigid body, and also bullet solver for rigid bodies. And we have a new Velum Solver from Houdini 17, which is a multi-solver, and all of its different operations can be seen under this Velum shelf tab. So the Velum Solver can calculate cloth, hair, soft body, balloon, grains, and simple cloth. So since I already demonstrated a rigid body simulation in the first lesson, we didn't actually dive inside the DOP network for it to see a typical data flow inside of DOPs. So I'm going to set that up manually. First, we need an RBD object. And our source has to be fetched. So here under SOP path, we have to define an object that we want to act as an RBD object. I'm going to go back to my object context and lay down a torus. So again, I'm holding shift and pressing on this torus shelf tool. And here we have our torus. Back in our DOPNet, I'm going to source this torus by clicking on this button over here. And I'm going to choose our torus object. So back up in object context, I'm getting rid of my box. And I'm just going to change my torus around a little bit. So I'm going to give it a bit more uniform scale. And I'm going to crank down the radius. Like so. Now I'm going to build something to collide with it. So this is going to be a static object, which is going to be for collisions. So I'm going to lay down a geometry node. And this is basically an empty container. And what I'm going to build here is 3 levels of boxes that are going to be angled so our torus can fall down in a dynamic manner. So I'm going to lay down a box. And I'm going to make it a bit wider in the Z-axis. So if I hold down shift and hover over one of these arrows, it's going to scale it uniformly on both sides. I'm going to do the same thing over here, but make it longer in the X-axis. Just going to adjust this like so. And what I want to do is, if I press the R shortcut, this gives me the rotation gizmo, and I'm just going to tilt it this way. Just going to make this a little bit wider. And now I'm going to make use of this little square right here. So this is going to constrain my transformation to X and Y. So I'm just going to put it down a little bit for our first collision object for the torus. Now here's something interesting. If I lay down a transform SOP and a merge SOP and merge these two together, I now have 2 boxes merged. One of them is the original and the second one will be the transformed. So if I go in the transform and change the X scale to -1, it's going to flip it, and then I'm going to again make use of this constraining transformation gizmo and move it down over here and maybe adjust it a little bit. So just to see how aligned our objects are, this is a good opportunity to show off the different views within the Houdini viewport. So by holding down space and pressing 2, we have our top view. So as we can see, we're perfectly aligned. If we press space 3, we get a front view, space 4 for right, and space 5 is for our UV view. If you press space 1 again, we'll be back in our perspective. Now I'm actually going to copy this transform SOP so we have 3 different boxes. So if I hold down Alt and drag this out, this is our 3rd box. I'm going to pipe it in our merge SOP and visualize everything. Now this one I'm going to scale back to our original. And I'm going to make use of our XY constraint gizmo to put it back over here. So I'm going to flip it +1 in the X-axis and just adjust it. So here we have sort of a collision obstacle for our torus to go through. Let's see what we can do with this. So back in the DOP network, what I need to lay down for this collider object is a static object. So here we can fetch the data for our collisions. So I'm doing the same thing as I did for the RBD object under SOP path. I'm going to fetch my geo. Okay, so if I pipe this in, we're going to see that it's displayed because we have this display geometry check mark on. I'm going to check this off for now, and in our collisions tab we can actually see our bullet data, which will show our outline for our collision. So as we can see, we have a bit of a problem here because this is making a convex hull operation for the static geometry. What we need to do is change it to concave and we're all good. So now I'm going to check this off and check display geometry back on. Alright, so now we need a solver to run the calculations of our dynamics. So I'm going to put down a bullet solver, and I'm going to put down a gravity force so we can get gravity. This value is the default real-world gravity, so I'm going to pipe this into our output. And the next thing we have to do is just merge our static object with our bullet solver, and actually we need to pipe this in our gravity. Now I'm going to pipe my RBD object inside the solver. And I'm going to click on the real-time toggle and see what this looks like. So here we have it. It's colliding with our geometry. What I'm going to do is reset the simulation and put down the friction on our collider. So this is sort of the roughness of it. So we're going to want to make the torus slide off. I'm going to crank this down to 0.5 and see what happens. So here it is. Our torus is sliding down our obstacle. I'm going to make use of a more interesting geometry for our RBD object. So if I type in test geometry, we have a variety of different meshes that come with Houdini. I'm going to put down this pig head. So Houdini ships with some of this geo, and it's already textured for us and UV'd and everything. So if I turn off this torus, we still see it because we're looking at our DOP network. I'm going to swap this torus with our pig head for our RBD object. And there goes our pig head. It's getting stuck, so I'm going to adjust our collider object. Like so, and like so. Okay, let's run it again. All right. Now what I'm going to do is turn this pig head into a soft body object. And here we can make use of the new Velum Solver within Houdini. I'm going to use the shelf tool for this. So all we have to do is select our object that we want to turn into a Velum operation. And here I'm going to click on Velum Strut Soft Body. So by running this shelf tool, Houdini adds some extra nodes to our DOP network. And we might have to rewire them. So yeah, it's these 4 nodes that Houdini added. In this case, we don't need this merge, and we're going to merge them at this point instead of down here. So I'm going to get rid of my rigid body sim. So we can either cut the wire by holding down Y and dragging across, or I can simply bypass our bullet solver. So let's see our Velum in action. So here we have this crazy soft body sim, floppy ears and all. I'm just going to put down the friction in here so it can slide more easily. And again, we're seeing both because I have the pig head visualized in the object context. The reason this came with a merge is because we can use as many objects as we want to collide with each other with our Velum sim. So I'm going to put this merge node back. And maybe we can include our torus in this sim. So I'm going to run the same operation on our torus. So I'm going to reset our timeline, click on the torus object, and click on Velum strut soft body. Okay, so now we have the torus object, and by the way, Velum is actually adding a bunch of nodes to our sources to initiate our values. We don't need to worry about that right now, but here what I'm going to do is move our torus up a bit. Okay, alright, so let's hit play and see what happens. And there we have it. We have both of these objects colliding with each other, as we can see at the beginning of this sim. Now I want to demonstrate a simple particle system, so I'm going to reset our timeline again and get rid of this Velum node, and we don't want our collision and pighead. So I'm going to have particles emit from this torus over here. So I'm actually going to delete our DOP network, and this time I'll put our DOP network inside our SOP. So if I flag the torus again, and I'm going to get rid of my Velum nodes, and maybe I'll reset this back to 0. So now I'm laying down a POP network. A POP network is basically a DOP network, except it's pre-configured with a particle solver. So our POP source is already pre-configured to use first context geometry, which means it's going to fetch whatever is plugged into our first input. Here under our birth tab, we have two different ways of birthing our particles. So impulse activation births this number of particles every frame, whereas constant activation births this amount of particles every second. So let's go with constant birth rate, and the default is 5,000. Let's see what happens. We've already got some particles going on here because we're on frame 1. And if I press play, more particles are going to be birthed, but nothing is happening because we have no forces applied inside our DOP network. I'm going to lay down a POP force node. And this is going to move our particles whichever direction we want. So let's have them move up by 1 unit. So now we have a very uniform movement upward. Let's crank our amplitude to get a bit of turbulence. And this is amplitude for noise, which is in the noise tab over here. Let's crank the swirl size for a more organic look. And maybe crank the turbulence itself. I'm just going to ease off on some of these values. And now we're going to try to make this collide with something. So since it's kind of hard to see when particles are colliding and when they aren't, I'm going to lay down a simple wide box for our collisions. So I can put it either in our object context or inside our SOP context. I'm going to put it in the SOP context. So here we have our box, and I'm just going to manipulate it with our gizmo. So again, I'm holding down Shift and dragging this out to make it wide, so it can be obvious that the particles are going to be avoiding it, and I'm going to drag it up. Let's make it just a little bit wider. And now we have to basically repeat the same method of putting down a static object, and I'm going to fetch my box. So under SOP path, if I click this button, here's my box inside our torus object container. And again, we need a merge, and we're merging our POP solver with the static object. Since I piped in my static object after the POP solver, we have an ordering issue. So all I have to do is click on the merge SOP and hit Shift R. This will reverse our wiring. Let's see what happens. So there you go. We don't see any particles going through the box, and the collision is happening successfully. So that's all I'm going to show in terms of dynamics today.